So next topic is the harmonics. Okay, that is the harmonics that is being generated in the converter. Since it is HVDC converter, the harmonics will increase. The HVDC converter introduced both in the AC as well as in the as a DC harmonics. Okay, since no matter what you do to converter, it has both input. Let's say either AC to DC or else we are converting in HVDC what all the high power AC into DC. That is high voltage DC. So they are introduced both the AC harmonics as well as the DC harmonics. That is AC harmonics is in the AC system side and the DC harmonics in the after conversion that is down the DC line. Okay. So what are the effects of it? And what are the effects that will cause due to the reasons of harmonics? One is the causes of power loss. Of course, there will be a harmonics means what happens? The power, the rated power which we want to, that we won't get, because that will be neglected as a loss. So there is a process of power loss. Next is the reason for interferences, and one more thing is the over voltage is due to the resonance. Okay, when there is a harmonic, when there is a fluctuation of, when there is a resonance, what happens? Some of the time there will be a over voltage contributed. That is over voltage due to what? Due to the reason for resonance. Okay, and the next thing is instability of the converter. And what we are doing? We are at the end of the session in the converter, what we are doing? We are controlling it. Okay. There are some losses and we are using the control strategies and we are using the control devices. We are controlling it. After in the last class we have discussed what are the control devices, SPC and Stanton and all that. Using that devices, what we are doing? We are controlling the record, what power. Okay, so by that, if there is some harmonics present, it means what will happen means the controlling system will also be not be stable. That is, there is an instability in the there is an instability in the converter control system. Next is difference between triple control system and the load management. Okay, so whenever the AC is being converted into DC, what happens? We all know that in basic system, that is AC will be in the sine wave and we are converting it to the DC. What happens from DC wave should be in the positive side, that is not a straight line. But what happens? We will be getting it as a square wave like that. There will be some movements in it. Okay, so what we need at the load management side. A pure DC we want it. We can't integrate the entire pure DC, but almost we have to convert it without any ripples. For that purpose, we have learned that there are multi-level converter systems also there. Okay, so what they have given means the amount of ripples that has been eliminated or it has been reduced. It cannot be eliminated. More or less they are trying to eliminate, but it can be reduced. Okay, so that is a problem that is arising due to the harmonics. These are the effects that causes due to the harmonics. And what are the classifications of this harmonics means? One is the characteristics harmonics and other one is non-characteristics harmonics. The characteristics harmonics will occur in any default, that is any basic system. Okay. If the system is an ideal converter system, even in an ideal converter system, these kind of harmonics will present. Okay, there won't be any. I haven't used any control devices over there. I haven't used any filters over there. Just a converter. Okay, just a converter with not much amount of switches or not much amount of leakage. That is said to be the ideal converter. It will default a converter. Okay, see that basic converter, what harmonics will present means there is a characteristics harmonics. So under characteristics harmonics, we will be studying about one is AC current harmonics and other one is the DC harmonics. Okay, so mostly this harmonics will affect what means the flow of current. Okay, so we will be studying the characteristics harmonics. We will be studying AC harmonics order. How it will be defined as, that is the AC harmonic order H is equal to NB plus or minus 1, and in the DC harmonics it is represented as H is equal to NB. And what it is N and what it is P means the N is the any integer. Okay, and then whether it will be any constant, that is based on the integer. We will be applying n number of them, then any natural number of any integers. Okay, and then this P is our number of pulses. Okay, so we know that the AC is when we converted into DC means there will be what? There is a pulsation in the waveform. That number of pulses, how much it is, that will be applying over here. To calculate the harmonics, by using this formula, we can able to calculate the harmonics order both in the AC current system as well as in the DC harmonics order system. That is, in AC harmonic order, it is H is equal to NP plus or minus 1. That is fluctuating. Okay, it's plus or minus 1. Since it is AC harmonics, that is more or less plus or minus 1. And since it is DC, there will be any fluctuation. That is no need of the plus or minus 1. That is H is equal to N into P. And this is the basic AC current harmonics that comes under the characteristics harmonics. Okay, so this is the current which has been applied into the transmission line. And here we are having a star to star connection, and here it is connecting a star and delta connection, star connection, and here it is star delta connection. Whatever we are getting, but our current input current is getting divided into what first the first line it is we are taking it as IA1, and in the second line we are taking it as IA2. Okay, and that is the first thing that is being given into the Hvdc converter. Okay, and the other side we have given it as 6 pulse converter. In the initial stage, I have told you that in Hvdc converter, what is the basic pulsation number for Hvdc converter? The basic pulsation number is what? The first class the pulse number 6. Okay, so here it is also 6 pulse converter means here it is also 6 what is the schematic diagram of this? Is a 12 pulse converter. Okay, is a schematic diagram for a 12 pulse converter, and this is our converted output, that is DC current ID. Okay, so for that, this how current ID how it will be, and what is the current IA1 the graph is given. Okay, when the current IA1 goes to this Hvdc converter, and the current ID is in the form of this waveform. Okay, the pulsation rate is kindly you will see the difference of the pulsation rate over here, and whenever the current IA2 goes to a 6 pulse converter, okay, to a 6 pulse converter, how will be the ID, that is the direct current that comes as an output towards the converter side, that will be like this. This is the pulse difference. The number of pulse being get increased means what happens means our harmonics order will get decreases. Okay, so for harmonic what happens if since H is equal to N into P. So can you able to see both are proportional. So if pulse increases, what happens? Harmonics will get decreased. So what happens that automatically our number of harmonics order will get decreased. Okay, so that's this is the calculations of AC harmonics. Okay, so there are two currents we have given in AC components. One is IA1 and another is IA2. What we are going to do is we are going to neglect these currents are getting overlapped. That condition we are going to neglect. Okay, so IA1 and IA2 are getting neglected. Okay, so for our convenience, what we have assumed is that omega t, that is the x-axis we have not a waveform, right? That is the omega t, we are taking it as 0. Okay, so that the waveform have an even symmetry. What we are going to consider, since omega t is 0, what only we are going to consider only the even symmetric side. Okay, so and other thing is what we are going to, we can say that it is half wave symmetry only we are going to consider. So if it is half wave symmetry only, means what happens? Above session will only come. Okay, that is 0, 45 degree, that is pi by 2, and again pi. Okay, so the what we are going to eliminate is we have not going to consider the even harmonics. So we are saying that even harmonics is 0. Okay, we will understand that. See, first you are going to consider that both the current IA1 and IA2 are getting overlap is getting neglected. That is the first thing we are going to assume. Next, what we are going to consider only the omega t we have taken it as 0 for our convenience, and if it is the omega t x-axis we have taken it only as 0 means what we are taking the symmetry is as even symmetry, or we can see it as half wave symmetry. So under that condition our harmonics, even harmonics will be 0. So only what will be in the existing state? Only the odd harmonics, that is 1, 3, 5. These harmonics will be in the existing condition. Okay. So first I am going to say that So about x-axis, we have taken a constant that is a now. I am considering. So about x-axis, omega t is 0. So I am taking this a naught as 0. So about y-axis, what happens? The waveform will be like this is in the form of pulses, right? So if it is omega t is 0. So about x-axis, I am taking this a is 0. So from 0 to along the y-axis. Okay, the pulses it can be in any level. Okay, it can be in any level. That I have taken this n. Okay, so about x-axis, what we are saying a naught is 0, and about y-axis we are taking this b n. Okay, so about x we are taking b n is 0. Okay, these are the considerations we are mentioning. So here for the A and the first formula for IA1. So IA1 is summation of 10 number of 0 to n integer values there. It may be of any kind of process. Okay. So summation n is equal to A n1 cos n omega t. If it is first thing, even harmonics is eliminated, only all things for first thing and considering the correct IA1. In the diagram, you can see the schematic diagram. First, the current IA1 we are going to just be given to the Hvdc converter that we will consider. That is IA1 is equal to summation A n1 cos n omega t. Okay, so that is what is this A n1 method? Okay, so this A n1 is 1 by pi of 1 by pi by 2 by 2 times. Okay, that is here. From here, okay, 5 by 2 over this direction. Okay. Here we have neglected this. This is only we have taken the half wave symmetry. So we have neglected this 5 by 2 by even that we have taken it as half wave symmetry. So under this condition is maximum, right? So this waveform is like this 5 wave is our maximum state, and then we have taken it as n to the is equal to n terms, and this is maximum. We have considered only the half wave symmetry. So 5 wave is maximum. Since it is 5 wave is maximum, since it is half wave symmetry, we are dividing it by another 2. Okay, so that is 1 by 5 by 2 by 2. The limits varies from 0 to 5 by 2. Okay. So under the given, what is ID cos n omega t is our this is done for A1. Okay, and now you can solve this. So what happens if the denominator go up means it is 5 by 4. So it is 1 by 5 by 4 times. Again we reverse means what happens 4 by 5. Simple mathematics calculation. Okay, so it is 4 by 5. The current ID is constant. We cannot integrate. We are going to integrate only the omega t with respect to the d omega t. So ID is integrated common on outside. The limit varies from 0 to 5 by 3, and it is cos n omega t d omega t. While integrating this cos n omega t with respect to d omega t, what will be getting? 1 by n sin n omega t. Okay, the limit varies from 0 to 5 by 3. Okay, that is the things follows. That is 4 by this 1 by n we apply it over here, right? So 1 into 4 into 4 by n into pi. That is 4 by n pi. Current ID into sin n. Upper limit is what? 5 by 3 minus of lower limit means sin 0 is 0. That is minus 0. Okay, so we know it to put this. I am just putting for it for your reference minus 0. Okay. And now this is the value for what? A n2. Okay. And now if n I am going to take only the odd harmonics, right? So I am considering this n is 3. The order of harmonics is 3. Okay. So or we can say that as triplet harmonics or order of 3. Okay. So they are substituted as n is equal to 3. It is the order of 3. Then what happens to A is equal to 4 by 3 pi current ID sin of instead of this n what will be substituting value 3. Okay, so 3 pi by 3. What happens? 3 and 3 will get cancelled. Again, sin pi value is what? 0. So while you are substituting the value for sin pi, that is a 0. What is our A equal then? It is 0. Okay, and this is for the triplet harmonics. That is the order of 3. Okay, and as I said, for AC NP plus or minus 1. So I am taking it as the concept K, either plus 1 or minus 1. Okay. So first initially I am going to say that A N1 has a odd values of K. Okay, that is NP minus 1, NP plus 1 from the two conditions. First we are taking that K is equal to minus 1 means I am taking this as N is equal to for 6 number of integer I am considering. Okay. When substituting N is equal to 6 and K is equal to the negative, that is odd values of K is minus 1. What will be our A N1 is equal to same procedure. If you do it means you can only solve this. Okay. So just we will be getting minus of 2 root 3 by N by N. Okay. For even values of K, it will be A1 is equal to 2, that is plus. Okay. 2 root 3 by N by N. Okay, this is the correct form which will be in the first line, that is IA1. Similarly for IA2, the same formula, that is summation of what it is here, then it is AN1 means here it is AN2. AN2 cos and omega t. The same procedure which we follow means here the limits varies from where to where. Here it is 0 to pi by 3. And for IA2, number of pulses IA2 is being given to where? To a 6 pulse converter, right? So 6 pulse converter, what will be the limit from 0 to pi by 6? And what I given to how many pulses are there? 6. So the limits varies from 0 to pi by 6. Okay. So the 0 to pi by 6 means we are going to say we have to apply the same integral formula. We will be getting that A N2 is equal to 4 pi b divided by 3 n pi of sin n pi by 2 plus sin n pi by 6. Okay. And for the n is equal to, here also we are going to consider the third order probabilities. That is for n is equal to 3 means what we will be getting A N2 is 0. Adding this both the current, that is the input current IA is equal to the current to the two lines, that is IA1 plus IA2. So while adding this, IA will be equal to the summation of only the order components. That is n is equal to 1, 3, 5 to infinite. Okay, it will be of any odd numbers. Okay, so that is IA1 plus IA2 of 2 comes in only the cos omega t. Since only the considered, that is half base will be considered. Even harmonics are eliminated or will be considered. Okay. So now on substituting this limit means what happens? N is equal to 1 and towards the infinite of limit, or else n is equal to 3 towards the infinite of limit. If you substitute this and we know the value for IA1 now and we know the value for IA2 by substituting the AN1 value in the equation of IA1 current value. Okay. So while we are substituting this to current, but this is the general formula. That is total current IA is equal to 4 root 3 by ID. This is constant. So we have taken from the entire time we have taken 4 root 3 by ID as common outside and the order of formulas. That is cos n, if it is n is 1 means what happens? It is n into omega. That is cos omega t. Okay. So like minus, we will be noticing plus minus plus minus again plus. It will be the k values or odd values of k or even values of k. In that consideration, cos omega t minus 1 by cos 11 omega t. The next 11th order probabilities. And then there are 13th order probabilities. This session is continuous. Okay. So first order, third order, fourth order, next 7th order, 9th order, all the odd order probabilities. Here the rate is toward 15, 17, all on what happens when some of them will get cancelled. Okay, so only here minus 1 by 23 cos 2 omega t and here 1 by 25 cos, sorry, 23 omega t is not cos 2, it is cos 23 omega t. Okay, so cos 1 by 11. So the value of minus 1 means that is cos omega t minus 1 by 11 cos 11 omega t plus 1 by 13 cos 13 omega t and minus cos 23 means if the order is 23 means 23, n value is 23 means 23 and then value is 25 means 25 and this way continues for up to what? Towards infinite. Okay. So now for 12 pulse converter, we are just taking up here for 12 pulse converter. What is the current? For taken I assume the current as I10. Okay. So the initial state itself, I have told you to assume that the current I1 and I2 will not overlap. We have neglected the overlap. So this 0 tells you what? This is the overlapping angle mu. Since we have neglected the overlapping condition, what is the value of mu then? 0. It is not I10. Take this I1 for the first order circuit, that is I1, and then 0 is what? The 0 is the overlapping angle. We have not considered the overlapping in the condition. So we have neglected the overlap. So we have assumed that mu value is 0, and this is predicting that mu value. Okay, so the first order parameter what is value I1, the mu overlapping angle is 0 is that is equal to what? 4, 3 by 5. IT by root 2. When we solve this, what happens? When we solve this, we can take this simple mathematical calculation. If we do it, what will be getting? 2 root 6 by pi into IT. That is the current I1. Okay, and then here for the harmonics current, what it is? Here also the 0 resembles the mu. Okay, here also the 0 resembles the overlapping angle. Okay, the current harmonics current has IH, that is equal to I10 divided by what is the harmonics, that is H. That H will be calculated by for AC system, that is NP plus R plus 1. Okay, that's all about harmonics and the two characteristics of harmonics, and under that this is AC current harmonics and its calculation.